Assalamu alaikum students. Hope all of you are fine and in the best of your health, taking care of yourself and your family, and you are studying wholeheartedly and understanding each and every topics. If you have any ambiguity, you can ask me on the WhatsApp group, or you can send me text, simple text or WhatsApp or through WhatsApp. Today we are continuing over lesson number 1. That part 1 we have done. In that we have discussed the refraction experiments and the process of refraction in detail. Now we will continue that with the index of refraction or refractive index. What is refractive index? It is the amount by which a transparent medium decreases the speed of light. It is actually the process by which any transparent medium refracts the light amount of light is known as refractive index. Its other definition is it's the ratio of speed of light in a vacuum compared to the speed of light in any medium. So what it means, the more denser the medium is, more value will be of index of refraction or refractive index. Both are the same terms. So refractive index will become more if the medium is denser, and as the density is more, the light will more bend towards the normal or away from the normal. It depends upon the medium. The second definition is the ratio of a speed of light in a vacuum compared to the speed of light in any medium is known as index of refraction, or again refractive index. It is represented by small n. We have discussed this one formula, n is equal to sin I over sin r. Now the other formula of refractive index is n is equal to c over v, where c is the speed of light in vacuum and v is the speed of light in any medium. This refractive index has no unit. What is the reason? What is the unit of speed of light, students? Of course, that is meter per second. The speed of light in medium, again the unit is meter per second. Meter per second divided by meter per second, both units will be cancelled and the answer will become 0. Oh, sorry, it will become a unitless quantity. So value of C, that is speed of light in vacuum, is 3 into 10 raised by 8 meter per second, and speed of light in any medium varies, that is water, is 2.26 10 raised to power 8 meter per second. Now we have to continue it with Snell's law. I have discussed that the index of refraction can also be considered or calculated by n1 sine theta 1 is equal to n2 sine theta 2, where n1 is the diffractive index of first medium, that is air, and n2 is the refractive index of second medium, that is water. If we are taking, or we are always taking the second medium as air, then we can also write n1 over n2 as equal to only n, as we have written in previously. Then n is equal to sin I over sin r. Okay, now we will proceed it by discussing its value in different mediums as well as some questions. The index of refraction for various mediums are, you can see in this table, the first values of vacuum, which has least value of refractive index. Its value is 1, whereas air has the value 1.0003. And if we come down in the table, this value decreases. Of pure water, the refractive index is 1.33. You should learn this value of vacuum and pure water. They are commonly used values. And if you come down, sapphire has, glass has refractive index of 1.52. Table salt, you should be able to tell, 1.51. Sapphire 1.77. Zircon or zirconia, one's is 1.92 and second one 2.16. Diamond has a very high refractive index as compared to other transparent materials, that is diamond. All of them are transparent materials. Transparent mediums can only show you the refraction and refractive index. And last one, which has the maximum value of refractive index, is gallium phosphide. Now let's do some questions related to marking schemes. You should be able to solve the questions related to refractive index and be able to write the answer according to their marking schemes. The first question is, the speed of light in a sample of glass is 1.91 into 10 raised by 8 meter per second. The speed of light in vacuum is 3 into 10 raised by 8 meter per second. What is the refractive index of thin glass? Now they have given the speed of light in glass, they have given the speed of light in vacuum. First of all, you always write the given data. So if you write the given data, nothing should be skipped. When you will do the calculation step by step, your answer will always come accurate. Now, first you will write the given values, then you will write the formula. What is always write the formula, students? Formula is very, very important. If you will not write the formula, you directly divide, you will never get full marks. So always, even calculation is of one number, you have to write the formula. It's very important part of calculation. N is equal to C over V. So when you put the value of C, 3 into 10 raised by 8 meter per second, the value of V, 1.91 10 raised by 8, and the value of refractive index will come out to be 1.57. Now it has no unit because refractive index is a unitless quantity. The second question, a light ray moves from water to glass. The angle of incidence in water is 26 degree. Calculate the refracted angle given in the index of refraction for water is 1.33 and glass is 2.04. Now in that, the angle of incidence of water is 26 degree. You have to calculate the refracted angle. You have to calculate basically the angle of refraction. The index of refraction of water is 1.33, it's given, and glass is 2.04. So of course here you will use Snell's law, n1 sine theta 1 is equal to n2 sine theta 2. The value of n1 and n2 are given, the value of sine theta 1 is given, but theta 2 you have to determine. So first you will calculate the value of this equation, then the value of sine theta will become 0.497. Then you will take sine inverse of this value. When you take sine inverse of this value, then the value come out to be 16.6. So the angle of refraction, a refracted angle of light ray moving from water to glass is 16.6 degree. Third question related to index of refraction is, what is the speed of light in water given that water has a refractive index of 1.33? Refractive index in water is 1.33, speed of light in vacuum 3 times by 8. You already know that. Simply apply the formula N is equal to C over V. You will do the calculations, and by putting the values, and the speed of light in water come out to be 2.26 10 raised by 8 meter per second. Again, you have to put the correct unit. The unit of speed of light is meter per second. Now, of course, you have to remember a few points from this lesson. First, we have discussed in the start about refraction, that when a ray of light passes from air to water, its speed changes. That gives a quick recap of all the topic we have studied. Due to this, there is a change in direction of the ray. When a ray of light passes from any transparent medium to any other transparent medium, its speed changes. You have to remember that. And due to that, its direction changes. The change in direction suffered by a ray of light as passes obliquely from one optical medium to another with different optical densities is known as refraction. When a ray of light is incident on a surface separating two media, a small refraction of light always gets reflected. Refraction can make object appear to be on a different position. I hope students, you have understood the lecture very well. Take care of yourself. Stay safe. Allah Hafiz.